So here at Brooklands you can study aeronautical engineering, motor vehicle, motorsport and manufacturing. We do very well for applications. It's a very popular department for the simple reason that there is a real future for all in these areas. There's so much you can do just because you do a manufacturing course. That doesn't restrict you to only manufacturing. There are many branches of engineering that you could move on to. Our students come from all over. They don't just come from the Weybridge or local areas. We have students travelling from Bognor and the other side of Essex to come and study the courses here because they don't run anywhere else and we run them extremely well. We think our facilities are wonderful and we look forward to being able to throw our doors open once again so that people can come and see for themselves. But the workshops are well equipped and extremely busy, and it's lovely to see people working in here. Can't wait for all the masks to go so that people can just work as normal. But yes, we have fantastic facilities in both construction, science and engineering.
So basically we've been studying drive shafts at the moment and how they work, and then we've been taking the wheel and the extra material that comes with all of that for you. It's not a ratchet.
Service of the red chair.
Did transition last year and did this as an option, and it just kind of like intrigued me to carry on.
We'll do a chisel edge on the side hole to see if we can get it to turn.
Brooklands doing his own vehicle. Because he's not due in today, he's just coming to do some extra. He's got an MOT failure and he's changing the bottom track control arm ball joint. He's done most of it himself so far, with a little bit of assistance. And he's just finishing off tightening that ball joint before we assemble the brakes and put the brakes back together this side.
What year you're in at Brooklands?
My third year.
Your third?
Yeah.
Enjoying it?
Yeah.
This is your own car, is it?
I'm still learning to drive, and then once I've done it, it's my car.
Oh, wow.
Over the drive shaft, release the pressure, slide the boot off. We're doing drive shafts today, front wheel drive shafts, inner tripod joints. The guys over there are taking the outer CV joints apart. Lewis is about to try and fit the clip back on now, which is a special type of clip, a circlip to retain that joint. Going to hold the shaft, Lewis, for me. Make sure that the joint goes the right way up. There's a little recess in there which sits over top of there to allow the joint to sit down as far as possible. And then we've got a little motion there where we slide the clip across the top, keeping the joint in place. And you should be able to stand at the table. You should be able to slip the clip in there. And it secures that in place. And then we've already replaced the joint on there and the boot so that we can fill up the grease and fit it to the extension shaft back on the car. Have a look at the top side of it. That's it. And then that facing up. So you've got to drop it in so that face is facing up.
It gives me a bit of insight on mechanics, gives me further insight on basically older cars and newer cars and more of an insight. Today we've been learning how to do the drive shafts and transmissions and stuff like that. You can tell it's a happy environment. All of us get along well and stuff like that.
Once you get off, especially if they're on the car.
I'm a mechanic at the moment, and in the future I'm looking to further work on cars and obviously work on my own car, and that's what this course helps on, working on your own car, saving money and stuff like that.
And then what you're going to do, one of each to close. And then here, turn. Okay? Just put it on the floor, just lay it down on the floor, flat. And you're going to hold. No, it doesn't matter which one going, but put the red one in there, the red one in the ground. Now you'll probably have to hold that with both hands, so you're holding the probe and the terminal. There's RAF gone. Now what you're doing is you're looking for a reading on there, so the black one in there, and then RAF, come round and turn the wheel, or what would be the wheel, and Harry should get a reading on that scale.
Go on, get the water up there.
But these cars, I believe, this is a Landina Formula 4 Bear. So I know more about it. So I've got to put these back onto the bits. That's what we're tasked with right now. Got a fuel issue we need to sort out. Got an alternator on the back of it, so it's got over here. Last time it was running slightly around here, the alternator caught fire. So we need to sort that out there. And it hasn't ran properly since 2013. But they got it running about 6 months ago before lockdown, and then like I said, that caught fire the second time they ran it. So it took it apart to rebuild it. So that's what we're doing right now. And then we've got
Trying to work out what's wrong with it.
yeah. So we've got today we're drilling out all those rivets, trying to get this off, so we can access under there, get all the fuel issues sorted out.
And that's the body for it, is it there?
Yeah, so all of that's got to go back on. We'll fix all the bits with it.
What level are you doing?
Level 3.
What do you like about studying at Brooklands?
The facilities here are really good. It's like all the workshop space and everything in here is like brilliant for doing car stuff. The lecturers really know their stuff.
What do you want to do after you leave?
I think I'd like to be on some kind of race team. Probably building and tuning up the cars. Who knows?
is one. He's a foundation degree second year student, which is equivalent to level 5. And today I'm going to show one our CNC lathe as part of his training at this level. Well, this is a CNC lathe. Most production machines will either be computer controlled. Unlikely you'll find many manually controlled machines anymore because you've got the repeatability of humans removed out of that equation. So it means you can rinse and repeat part production. Kind of finish cut. So if I list the operations, what I tend to do with students is I tend to show them the lathe first. In machine terms, it's the grandfather of all machine tools, and so it's a good place to start where machine tools started, which is with the lathe. Now the nice thing is with this is I've got obviously drawings pre-done, I've got the tools out and ready, it's kind of been set up. I'm just going to calibrate it, run through the programming with one, and then yeah, we'll go from there. We'll start chewing up some metal. In my opinion, you can't ever have enough coolant on an internal bore because of the high pressure. So we can run this down. Here it's got faster. One of the things is when machining is surface speed. Surface speed is how fast the cutter is crossing the metal. Now the surface speed on a small diameter will be fast.
As with all our vocational areas, engineering students are able to benefit from the excellent work experience placements, some ending up securing full-time positions following successful completion of their course. Some of the companies we've been working with include Daytona Racing, Merit Tyres, Mercedes-Benz World, West Surrey Racing, D&D Automobile Engineering, Fair Oaks Airport, Brooklands Museum, McLaren, ALP Racing and Farnborough Airport. These work placements supplement the students' college-based learning, providing the essential on-the-job experience. Students are also able to learn key skills such as team working and communication and develop a sense of independence. Their exposure to the industry can help students decide which pathway is right for them on completion of the course.
So this is a level 1 manufacturing course. What we're doing today is we're making this, which is an angle finder, which they've riveted together, 3 bits of metal. It involves marking out, drilling, tapping a hole, quite a bit of filing. What we're going for is a high quality finish. So this is from blank metal. So when I came here a long time ago, this is what they're actually making. This is what I made about 30 years ago. And this is what they're attempting to make. Combination square. Set it to 190. Set it to 190. Push it through the other way. So look, it's going to be quite long, isn't it? 190. 190 there. Line it up, line. Yeah. You've got that hands up. Yeah. Okay. So next you lay your work down. Put it on there and you'll scribe the line across there. That's that front edge. So you need a cool. Excellent. Right. you're going to start, I think you're on the soft piece or the steel part. Let me show you spreading when it gets back. We'll do the shams up here. So yeah, on like that. You've got a choice of two methods. I'll use the strip of steel, or it's drill backwards and forwards, or line it up with the wood there. This is level 2 manufacturing, and we're doing machining, turning. So we have a turning exercise, which is for their assessment. Deburring, dragging the file backwards. Yeah. Take it. Right, I wouldn't do too much for it. First thing you want to do, place like the chuck and the face of it like that. Get it started. Yes. Right. So, have a little chuck. Set your tool to tool height. Yeah. Okay, you're right. So set that up. Face off. We'll do exactly the same. That's exactly right. Up in there, then you can either use your centre and strip the steel to get it.
And they're easy to use separately.
I prefer doing the strip of steel so you can get more out.
Hi, these are the level 3 aerospace maintenance students, and they're currently been introduced to aircraft skin repairs and some of the detail fitting that's required for it. We're making a template at the moment, which is going to be used to make duplicate double plates at the back, and they're also making 3-inch patches, so when we take away their corrosion, impact damage, etc., we can make it to a true size. They've only been with us for a few weeks now, and they're currently getting used to using the hand tools and marking out as accurately as possible. We've been using height gauges for making templates, and they're also using a pencil and rule method with a compass to pitch holes, and they're making a pretty good job of it. I'm pleased with them so far.
Because if it's slightly short, it doesn't matter. Because the circle is going to be smaller than that anyway. Right. The big one. So when we hit the big one, that goes in the back, that goes into the hole, we rip the hole into it. Big enough to put the hole on. We'll give it a go on So we've got to put multiple papers on first. We've got multiple papers on
I like the practical side and also learning the theory side, so we're learning about the aircraft, which is what I like to learn about.
Okay. Why did you choose to study at Brooklands?
I wanted to go into aeronautics or digital design. I went for aeronautics course because I found out it would be more like what I'm interested in.
Okay. And what do you want to do in the future?
Become an aircraft engineer, either civil or in the military.
It's measuring, I think, the height of the ground.
Okay.
So I'm like elevating the piece, and then it's got the exact centimetres in it. Or is
set your compass at double reach back, check it at the time and draw that. And then you can, to be honest, it's easier to do the bigger one first.
Yeah.
And then work back in. Yeah. This is nice. Yeah. Some people might find this method easier.
Well, if you go 1.5 in the centre, yeah, don't need one.
So whilst you're waiting now, get yourself in the tractor.
Students interested in aeronautical engineering are able to study both a Level 2 and 3 aircraft maintenance qualification at Brooklands College. Students develop key skills and acquire valuable experience in this fast-paced, challenging engineering sector. Combining study with practical learning, our aeronautical courses offer us an exciting foundation for a career in the aeronautical engineering industry. Brooklands students, of course, benefit from the proximity of both Heathrow and Gatwick airports, offering a range of job opportunities. The courses teach the basics of aviation engineering, studying subjects such as the fundamentals of aviation science, airframe construction, electronic principles, and the theory of flight.